Hi everyone, in this video we are going to talk about binary numbers and any data that you stored inside your computer is actually stored in a binary format, right? So as you know that binary number system has a base of 2, which means it has only two unique digits, 0 and 1, right? So any data that you write in your program or also an image or anything, right? So that is just stored as a list of numbers, right? And each number is nothing but a list of zeros and ones. And the reason being is very simple, because whatever data you stored, right? So you cannot create a 5 inside a memory of a computer, right? So you have small cells, and that cells can store certain charge. Let's say it can store some charge of V volts. Then we can say, okay, it is having 1. If that charge is 0 or less than V volts or minus V volt, we say, okay, this is 0. So we discretize the voltage, right? Discretize the voltage levels, right? So if that voltage is beyond a certain threshold, we say it is 1. If the voltage is less than the certain threshold, we say it is 1, right? So if you want to store 5, so the way 5 is actually stored inside the computer is it is written as 101, right? So how do we interpret this binary data, right? So let's see how we can actually see it as 5, right? So let us first talk about decimal number system, right? So in decimal number system, you have a base of 10 and you have 10 unique digits. You have 0, 1, 2, 3 up to 9. And any number, let's say number is 1, 2, 4, and you interpret this number as it is 100 plus 20 plus 4. So if you want to break down this number, you will say, okay, 4 is multiplied with the 10 power 0, 2 is multiplied with the 10 power 1, and 1 is multiplied with the 10 power 2. So this is nothing but 100 plus 20 plus 4, that makes it 124. So if you're given a number like this and it is said that this is a binary number, right, and you want to convert this number into a decimal number system, then you have to multiply with the powers of 2. So if this number is 101, you will say, okay, I will generate powers of 2. So 2 raised to the power 0, 2 raised to the power 1, 2 square, 2 cube, and so on, right? And you have all zeros here, right? So if you multiply 1 with 2 raised to the power 0, you will get 1. If you multiply 0 with 2 raised to the power 1, you will get 0. And if you multiply 1 with 2 square, that is 4. So you will get 4. And rest everything will be 0. So if you add on these terms, you will get 5. Right? So similarly, if I give you one more example, if the number is 1101, so can you guess what is the equivalent number in decimal? So this is nothing but 2 raised to the power 0, which is 2 raised to the power 1. This is 2 square, this is 2 cube. So you will add 8 plus 4 plus 0 plus 1, which is now 13, right? So this is exactly how the number 13 is stored inside the memory of the computer, and this is the binary equivalent of 13, right? So you have learned how to convert a number, how to convert a binary number into a decimal number. Let us also look at the reverse process. Okay, how to convert a number from decimal number system into binary. Okay, so the way to do it is you will repeatedly divide by 2, right? So let's say we have 13. So I can say, okay, 2 6 are 12 and the remainder is 1. Then I say, okay, 2 3s are 6 and the remainder is 0. Then I can say 2 1s are 2 and the remainder is again 1. Then I can say, okay, 2 zeros are 0 and the remainder is 1, right? So if you interpret this from this direction, 1101, so this is nothing but the binary equivalent of 13, right? So another way to write is you look at how you can make 13s by using powers of 2, right? So what is the largest power of 2 that you can use to make 13, right? So power of 2 is like 1, 2, 4, 8, 16, 32 and so on, right? So clearly you can say I can use 8. If I use 8, I'm left with 5. What is the next power I can use? I can use 4. Okay, what you are left with 1. So 8 plus 4 is 12. So you're left with 1. So you will not consider 2, you will consider 1. So we skip this and we consider 1. So this becomes 1, this becomes 1, this digit becomes 0, this becomes 1. So this is another way you can convert a number into its binary format, right? Let me give you one more example. Suppose you want to write the binary equivalent of 18, right? This can be expressed as 16 plus 0 plus 2 plus 0, right? So I'm writing powers of 2 here. 2, 1, 2 square, 2 cube, 2 raised to the power 4. Sorry. So this should be like this: 16 plus 0 plus 0 plus 2 plus 0. So this is 1 0 0 1 0, right? So this is how you can actually write this number as in the binary format, right? Okay, and you can see if the magnitude of number increases, you need more bits, right? You need more bits because a higher power of 2 is involved, and that will have a higher index, and that will require more number of bits to store that particular number, right? So this is about the basic binary number system and how you can convert between binary to decimal and vice versa. In the next video, we will write one program based upon the same concept.